Hey guys, Dr. Brown here with Kubo Math, and this is by special request. Yesterday I put together a video on what is a derivative for some high school students who were asking that question, and in that video I had gone through the limit formula showing them how to take a derivative using the limit, and I threw up there sine x and why we can't just use a power rule for that, and I said I'm just going to leave that up to you guys to do that. Well, everybody's hair has caught on fire. So let me take time and go through the derivative of sine x using the limit formula. Now we know the derivative of sine x is cosine x, so that should be our answer. Okay. Now if you didn't know already that derivative of sine x is cosine x, you need to do some studying. Okay, derivative of using the limit formula, and recall the limit formula then is the limit is h approaches 0 of f of x plus h minus f of x over h. So let's take, and the limit is h approaches 0 of sine x plus h minus f of x is sine x over h. Now I've written down a formula here relative to the sine of x plus h. It's sine x. Sine of this angle is, there's two angles here, x and h, okay? So sine of x times cosine of h. That's not hyperbolic cosine, that's just cosine of angle h plus cosine of x times sine of h. All right, so we can use that identity then and replace this term, sine of x plus h, with these items here. So let's do that. We have the limit is h approaches 0 of sine x cosine h plus cosine x sine h. All right, so that took care of this term, minus this guy here, sine x all over h. Now you'll notice I have a sine x term here and a sine x term there. I'm going to factor those out. When in doubt, factor. Okay? Alright, so now I have the limit is h approaches 0. I'll put the sine x over here in just a moment, but for now we'll just factor it and leave it here. And that's sine x times what? Cosine h minus 1. So sine x times 1 gives me this, or times a negative 1 gives me a negative sine x here, plus this term cosine x sine h all over h. Actually, I'm going to put this over h and that over h. It's the same as it all being over h. Now then, since there's no h in this term, I can pull it out. Sine x times the limit is h approaches 0 of cosine h minus 1 over h plus cosine x times the limit is h, is h approaches 0 of sine h over h. I need my 0 here. Limit is h approaches 0. Okay, that looks better. Now, obviously, as h gets closer to 0, cosine of 0 is 1. So as h approaches 0, this term wipes out and just becomes 0. It approaches 0, 0 times sine x, all of this is gone. Now, the limit as h approaches 0 of sine h over h is 1. Now that's not so obvious, but let's assume h is 1 times 10 to the minus 6. So, put your calculator on radians. The sine of 1 times 10 to the minus 6 is 1 times 10 to the minus 6. And that divided by 1 times 10 to the minus 6 is 1. 1 times cosine x equals cosine x, which is what we should have ended up with because the derivative of sine x is cosine x. And that is how you would use the limit formula to take a derivative. Now, some people might say, well, how do you know? I had videos on this once before. How do you know that formula is correct? Well, back in the day, all right, I'm going to erase this if you guys are okay with that. Back in the day, we were required to remember two triangles. Let's say this is 45 degrees, okay? That would be 1 square root 2. Now here's 30 degrees. Oh, and by the way, that's pi over 4. 30 degrees is pi over 6. So that's 1 square root 3, 2. We were required to remember these, and it's so handy, by the way, and you'll see why in just a moment. This is pre-calculator days, by the way. To me, it gave a little bit greater insight into some things. Okay, so let's say the sine of 45 degrees is opposite over hypotenuse, 1 over square root 2. Cosine 45 degrees equals the adjacent over hypotenuse, 1 over square root 2. Let's work on this one. Sine of 30 degrees, opposite over hypotenuse. Cosine 30 degrees, adjacent over hypotenuse. Okay, now if we said sum of two angles, if I have a 30 degree angle plus a 45 degree angle, well, 30 plus 45 is 75, right? But I could say this is sine of 30 degrees plus 45 degrees. And that should equal sine of 30 times cosine of 45 plus cosine of 30 times sine of 45 degrees. Okay, what is the sine of 30 degrees? Sine of 30 is 1/2. Cosine of 45, it's 1 over square root 2. Plus cosine of 30, cosine of 30 is square root 3 over 2, and that's times sine of 45, which is 1 over square root 2. Now you'll notice, I know the mathematicians are falling on their pencil right now because I have a square root, radical in the denominator, but hang loose, okay? 2 times square root of 2 in the denominator, and also 2 square root 2 in the denominator. So I can let that be my common denominator. So 1 times 1 is 1 plus square root 3 times 1, square root 3. If you take and put this in your calculator, you'll get, now back in the day we would leave it this way from when I went to school, 0.9659. If you take the sine of 75 degrees, sine, and that's 30 plus 45, you will get 0.9659. So from this, I can feel comfortable using that formula, the sum of two angles. Okay, all right, so this is to answer all the questions that came up about, how do I take the sine x and work through that, taking the derivative of sine and getting cosine x by use of the limit formula. Why are we doing this? Together we're trying to build a better tomorrow and do that through math, okay? Let's keep studying, keep working as many problems as you can, and I'll talk to you next time. Thanks.